Hey now, we're gonna do some Code Wars, some Code Katas. Let's go ahead and dive into it. The one we're on now is RGB to hex conversion. So what it wants us to do is we need to take our function that's incomplete. We need to complete it so when we pass in RGB decimal values, which are these, it'll result in a hexadecimal representation, which is this. Valid decimal values for RGB are 0 to 255. Any values that fall out of that range must be rounded to the closest valid value. Our answer should always be 6 characters long. Sometimes you can do it with the shorthand where it's half with 3 characters, and it's saying that it will not accept that. So cool. So let's go ahead and bring it down locally. So let's open it up in VS Code. We can bring our title in, and then let's bring our function in. Let's bring our test in. Start up Quokka. So we're given our RGB value, and we need to ultimately return a hexadecimal value, which is this. And RGB values, it stands for red, green, and blue. So it returns a color, and so does the hexadecimal. It will also return a color. So what we want to do first of all, so we need to look at each of these values, and we need to we want to create a function that changes we need to create a function that will change each number into its hexadecimal form. So I think what we want to do for this is we want to create a helper function, and we'll call it 2hex, and we'll pass in our number. And if our number, we want our number, if it's above 255 or below 0, we need to bring it down. We need to bring it down to 255 to our highest number, or we need to bring it up to our lowest number, which is 0. So we'll say C equals, if C is greater than 255, then we want C to equal 255. If it's above 255, we'll bring it down to 255. Else, if C is less than 0, then we want C to equal 0, or else we'll just return C, like that. So the next thing we want to do is we want to change it into our hex value. So what we're going to do is we're going to say let hex equal C, which is our number, and we want to say toString, and we want to pass in 16. And then at the end of that, all we need to do is return if our hex.length is equal to 1, then we want to add our 0 to it. So we'll say 0 plus our hex, or else we just want to return our hex. So then down here, all we need to do is we need to return 2 hex. We'll use our helper function that we created. We'll call it here, and we'll pass in our R value. We'll say plus 2 hex, and we'll pass in our green value. And then we'll say 2 hex our blue value. And so now you can see that we are getting our correct values passed in, but we need to capitalize these. So what we'll do is we'll go ahead and put this whole thing in quotes. We'll say to uppercase. And now we should have our correct values. So you can see it all matches up. So let's throw it into Code War, see if it works. Let's attempt. And so all our tests passed, and now let's submit. Okay, so we can see so you can see everybody did pretty much the same thing. They used the map. Cool. All right, so let's keep cruising. Directions reduction. So a man was given directions to go from one point to another. The directions were north, south, west, east. Clearly north and south are opposite, west and east are opposite. Going to one direction and coming back the opposite direction right away is needless. Since this is the Wild West with dreadful weather and not much water, it's important to save yourself some energy, otherwise you might die of thirst. So how I cross the mountain does it the smart way. Directions are given to the man, for example, the following depending on the language. So we'll get north, we'll get an array of directions: north, south, south, east, west. You can immediately see that going north and then going immediately south is not reasonable. Better stay in the same place. So the task is to give the man a simplified version of the plan. A better plan case would simply be just go west. So as north and south would cancel each other out. I guess north and south here would cancel each other out. East and west would cancel each other out. So we end up with just west by itself. So our task is to write a function which will take an array of strings and return an array of strings with the needless directions removed. Cool. All right, so let's do it. Let's go ahead and save the last one we did. We can get rid of it. Let's bring our title in here. Let's train. Grab our function. And let's grab our test. And we will change these to logs. And then we can bring these down like that. And start up Quokka. So right now we're getting undefined return. This is our ultimately what we want our output to be. So I think what we want to do is we're gonna have to look at each value of the array, and if they're not equal to each other, in a weird way to solve this one, I think that will work is you notice that the opposite ones, north and south, are both 5 letters long, and east and west are both 4 letters long. So I think we can compare them by the length of the word. And if they're the same, then we know they cancel each other out. So I think what we could say is we could go ahead and loop through our array. And we want to say -1. And then we want to say if array, we'll go ahead and check and see if they're the same. So we'll say if array at index is not equal to our array at index +1. So if the letter we're looking at is not equal to if the value that we're looking at is not equal to the value ahead of it, and we want to check their length, and if array at index dot length is equal to array at index +1 dot length. So if the length of the two words, why is it complaining? Oh, we need to get rid of this y. So if they're not the same, the two, we're gonna look at 2 at a time. If they're not the same and their lengths are the same, then we know that we need to remove them. We know that they cancel each other out. It'll be north and south or east and west. So we can splice them out. We'll say array dot splice, and we want to start at our index, and we want to remove 2 values, and then we need to return our index back to -1 and have it keep going at them because we're taking the 2 values out. So now everything else will shift down. So we'll say index equals -1, and then and with all this, we're manipulating this array that's being passed in. So at the end, we just need to return it. And that should work. West, west, northwest, southeast, northwest, southeast, empty array, empty array. So that works. So let's put it in Code Wars. Let's test it. All our tests pass. Let's attempt. Everything passed. Very cool. So let's submit and see how everybody else solved it. Okay. So they did a reduce. they joined the two opposites together both ways, north-south, south-north, east-west, west-east. And they just went through the string and checked for them. Cool. All right, let's keep it rolling. Where are my anagrams at? What is an anagram? Two words are an anagram if both of them contain the same letters. So the letters could be in different places in the word, but if the words have the same letters, then it's an anagram. So you can see here Abba and Bab. I mean, you know. True. False. This word has one more B than this word. So we're going to be given a word to check against, and we need to go through this array here and check and see which ones are anagrams, and we'll return the ones that are anagrams. Cool. Bring our title in. Let's go ahead and save this last one we did and get rid of it. So it looks like this one doesn't have any tests, but that's okay. We can, we'll steal some of these tests from over here. So let's go ahead and put in a log here, and we'll put in a log here. Let's steal some of these tests. We need to change this to a comma. All right, start up Quokka. So what we're going to want to do, we're given this word, and we want to compare it against all of these other words and see if any of these are anagrams. And then return the ones that are. So I think the way we're going to do it is we're going to sort our first word, and then we're going to go through our array and sort all those words and compare them. And if they're the same, then we know that they're anagrams, because they'll have the same amount of letters and the same letters. So we'll go ahead and we'll let word equal word dot, and we need to split it. We need to turn it into an array, because right now it's just a string. So we'll say word dot split. We'll split it, and then we'll sort it, and then we will join it, and that will give us our word with the letters sorted from A to Z. So if we go ahead and log our word, you can see A, B, A, C, E, R. So now it's sorted alphabetically. Now what we'll do is we will loop through our words. And we'll take, we'll go ahead and let our current word that we're looking at, we want to have it sorted. So we'll say let current word equal our word at index, words at index. That'll take our individual word, and we'll go ahead and do what we did up top. We'll split it. We will sort it, and we will join it back together. So then we can just say if our current word got a phone call. So if our current word is equal to our word, then we're going to want to store it somewhere. So we'll go ahead and create a place for that. We'll say let anagram equal an empty array. So we'll say here, if the two words are equal, then we'll say anagram dot push our word that we're looking at. And then all we need to do is return our anagram. Oh, wait, hang on. What are we messing up? Oh, this needs to be words. Right? So now you can see we are getting our correct word, our words that are anagrams returned. So that works. So let's put it in Code Wars. And it fails. Why? If our current word is equal to our word, then we want to push our word index, and we return our anagram. No? Oh, the reason why it's failing is because we don't have any tests here. We had to remember we had to make our own test, so that's why. So let's go ahead and attempt it where they do have tests set up and they pass. Cool. So let's go ahead and see other people's solutions. Okay. So, they made their own sort function, which you should not do normally. Bad form. They used a filter. Cool. All right, let's keep moving. Needle in the haystack. Can you find the needle in the haystack? Let's write a function that takes in an array of words here, full of junk words, but it contains one needle. Here's our needle. After your function finds the needle, it should return a message as a string that says found the needle at position, and then we need to return what index we found the needle. Cool. Let's go back and let's save this one, get rid of it. Let's bring in our title on our new one. Let's train. Let's bring in our function. Okay. So let's grab all of this. Oh my god. So I think all we're going to need to do, start up Quokka. All we need to do is we need to return. There's a built-in method that it'll find the index of a certain value. Whatever value you pass into it, it'll find the index. So I think what we can do is we can say, let's return, when you return our string, it says found the needle at position, and then we need to pass in our position. The way we'll do that, we'll say haystack dot index of, and we want to find the index of needle. And I think that should work. Found the needle at position. Found the needle at position 3. Found the needle at position 3. Found the needle at position 5. Found the needle at position 5. So it works. So that one's super simple. We just returned our string and we popped in the value with the index of where the word needle is. So let's put it, let's try it out in Code Wars. Let's test it. Passed. Let's attempt it. Passed. Let's submit. Cool. So they did the same thing here. They used concatenation instead of our backticks. This is what we did. This is insane. Crazy. Cool. Let's go ahead and do one more real quick. Split strings. So it wants us to complete the solution so that it splits the string into pairs of 2 characters. If the string contains an odd number of characters, then it should replace the missing second character of the final pair with an underscore. So we're given a string and we need to split it into doubles. Cool. So we're getting undefined return now. This is our expected output. So we need to check if it's odd from the get-go. If it's odd, then we need to add the underscore to the end of it. So we'll say let string equal if string dot length remainder 2 is equal to 0. That means we know it's even. Then we just need to return our string. Else we want to return our string plus our underscore. So if we log our string out now, then you can see we're getting, if it's an odd number, we're getting the underscore added to it. So the next thing we need to do is we need to loop through and if loop through, and we need a place to store our doubles. So we'll say let doubles equal an empty array. Now let's loop through it, and we'll start adding 2 at a time. We don't want that capitalized. So we want to say doubles.push our string at index plus our string at index plus 1. So that'll push into our array the letter that we're looking at in the string plus the letter in front of it. So that'll give us doubles. And so if we go ahead and we can return doubles now, and you'll see, and we need this to be length -1. But see, the problem is it's giving us AB and then BC and then CD and then DE, when really all we want is we don't want to start with every other letter. So this BC we don't need, the DE we don't need. All we need is A, B, C, D, and E, F. So what we can do is we can return doubles, and we can filter it. And our filter can take in, we don't need our value, so we can put an underscore for that, and then we need our index. And we want to filter out the ones that are indexes that are odd. So we'll say we want to return our index where the remainder is 0. And that'll take out all our odd indexes. So now we have the right values. If you check that out here. So that works. Let's put it in Code Wars. Let's test it. Cool, passed. Let's attempt it. And that passes. Cool. Oh. So let's submit. See how everybody else did it. New array. Add in our underscore. And then they're incrementing I by 2, which is, that makes sense. That's a cool solution. They're just using a match. This is a bunch of regex that I have no idea what they're doing. Cool. So I mean, all pretty much the same. But I think that's it for today. Thank you for watching. Have a good day. Peace.